Let's turn our attentions to logarithmic equations and how to solve them. A logarithmic equation is an equation where our variable occurs inside a logarithm. Much like exponential functions, logarithmic functions are also one-to-one. Writing this symbolically, we say that the log base a of x is equal to the log base a of y implies that x is equal to y. Let's use this property to solve a logarithmic equation. Example 5. Solve the equation given by the following. The log of x squared plus 1 is equal to the log of x minus 2 plus the log of x plus 3. To solve this equation, let's go ahead and use our properties of logarithms to combine the sum of two logarithms into one logarithmic function. The right-hand side then becomes the log of x minus 2 times x plus 3, and this is still equal to the log of x squared plus 1. Now, applying the fact that logarithms are one-to-one, we get that the argument of the log on the left is going to be equal to the argument of the log on the right. X squared plus 1 is then equal to x minus 2 times an x plus 3. Foiling out the right-hand side, we're going to get an x squared plus x minus 6. Now we just need to go ahead and solve for x. Subtracting an x squared on the right-hand side subtracts a x squared on the left-hand side, and we're left with 1 is equal to x minus 6. Subtracting a negative 6 on both sides, we get that x is equal to 7. Excuse me, I should have said x, adding a plus 6 on both sides. So the solution to this logarithmic equation is x is equal to 7. All right, let's go ahead and look at another type of logarithmic equation. Example 6. Solve the equation. This is going to be the log base 9 of x minus 5 plus the log base 9 of x plus 3 is equal to 1. This time we can't use the fact that logarithms are one-to-one. So instead, let's go ahead and combine this logarithm, the sum of these two logarithms, into one logarithm. The left-hand side simplifies to be the log base 9 of x minus 5 times an x plus 3 is equal to 1. Now, one thing that we know is that we have the logarithm of some number here, and this is equal to 1. Let's go ahead and rewrite this equation as an exponential. Equivalently, then we can rewrite this as an x minus 5 times an x plus 3 is equal to 9 raised to the 1. Let's go ahead and start a new page real fast. Now, on the left-hand side, let's go ahead and multiply out. This becomes an x squared minus 2x minus 15 is equal to 9. Subtract 9 on both sides. We're left with the following polynomial equation. X squared minus 2x minus 24 is equal to 0. Factoring our polynomial, we get an x minus 6 times an x plus 4. This is equal to 0. The solution to our logarithmic equation then is going to be either a 6 or a negative 4. So while we just found the possible x values that our x's can be, we have to make sure that these values are inside the domain of our logarithms. Let's go ahead and bring the original equation back. So here's our original equation. Now, if we plugged in a negative 4, what we're going to get then is a log of 9 of a negative 9 plus the log base 9 of negative 1. And this is equal to 1. So this is not a solution, and the reason why is because the domain of our logarithm is between 0 and infinity. and this is undefined for both of these terms. So -4 is not a solution to this equation. Let's go ahead and look at our other solution. So this is going to be the log base 9 evaluated at 6, which is 1, plus the log base 9 of 6 plus 3, which is 9, and this is equal to 1. This term is 0, the other term is 1, which is equal to 1. So x is equal to 6 is the only solution to this equation. Let's solve one more exponential or logarithmic equation. This is example 7. And let's solve this equation graphically. The equation that we're given is EX is equal to negative x. We can rewrite this equation as EX plus x is equal to 0. Then let's go ahead and set the left hand equal to a function. F of x is equal to the function e to the x plus x here. If we graph this function, then we want to find the point on our graph where our y values are 0, and so we want to find the x-intercept. So let me go ahead and sketch the graph. The graph of our function looks something like this. And we're given, if we graph it using Mathematica or a calculator, that this point here is the point approximately negative 0.567. Therefore, the solution to this equation is x is equal to a negative 0.567.